Hello there, this is Ms. Nakayama, and today's lesson is L.2 Linear Relations and Functions. So in L.1, we talked about just relations and functions. L.2 is going to concentrate specifically on those that are linear versus nonlinear. So an equation such as x plus y equals 5 is linear because it has no other operations other than addition, subtraction, and multiplication of a variable by a constant. Okay, so you got to keep in mind, and y'all can read that, so let me go on. Linear equations, these are all examples of linear equations. Okay, it could have two variables, it could have one variable, but look at these that are nonlinear equations. Okay, they are nonlinear if you have an exponent that is higher than 1. It is nonlinear if you have a radical, because that is a fraction that is 1/2. X to the 1/2 is the same thing as the square root of x. You cannot multiply a variable by another one, and you can't have a variable in the denominator. So those are the main things to look out for to be able to distinguish a linear versus a nonlinear. Now, a linear function is a function with ordered pairs that satisfy a linear equation. Okay, what the form that you should be familiar with is this right here. Instead of f of x, you might think of y equals mx plus b, where m and b are real numbers. But more importantly, it's a linear function if you think about the first four letters of the word linear, because every time you graph it, you get a line. So you've got to be able to distinguish by looking at an equation whether or not it's linear. So each of these we're going to go through real quickly, and a great thing to do would be to pause the video, try them yourself, and then quickly see how well you did by checking your answers. So first, f of x equals 8 minus 3/4 x. Is it a function? Yes, it is, and you can just say it's got the form of y equals mx plus b. B, f of x equals 2 over x. Is that a linear function? No, it's not, because we got a variable in the denominator. Can't have that for it to be linear. G of xy equals, this is C, g of xy equals 3xy minus 4. Is that a linear function? And the answer is no, it's not, because we can't multiply the variables. 1a says f of x equals 5 over x plus 6. Is that a linear function? No, because I cannot have variables in the denominator. And 1b, g of x equals negative 3/2 x plus 1/3. And the answer to that is yes, it is. And people kind of get misled, but it's similar to the first one. Okay, x is not in the denominator, so it's fine, and it has that form of y equals mx plus b. So a quick little application. The growth rate, this is example 2, the growth rate of a sample of Bermuda grass is given by the function f of x equals 5.9x plus 3.25, where f of x is the total height in inches x days after an initial measurement. How tall is the sample after 3 days? Well, after 3 days, then we're going to go take 3 and we're going to go plug it into f of x. So when I first write that, I'm going to, because I think it's a good practice, everywhere I have the variable x, I'm going to put parentheses, and instead I'm going to put a 3. So f of 3 equals 5.9 times 3 plus 3.25. And that, of course, equals 20.95 inches. Part B says, if the Bermuda grass is 50.45 inches tall, how many days has it been since it was last cut? And one of the things to look out for, y'all, if it says how many days, and if you're struggling at all, look back up here at the original problem. And days is defined with the x variable tells you how many days. Well, that lets you know that 50.45 has to be your y variable. So I'm putting that in for f of x, and I'm going to find out what x is that gives me 50.45. So subtract 3.25 and divide by 5.9. You find out that x equals 8. So it has been 8 days since it was last cut. Okay? Something else I know you're familiar with, so I'm going kind of fast. You need to slow me down. You can do that in YouTube. or in the video. The standard form of a linear equation is ax plus by equals c. Now, some of the things you might not be aware of is a, b, and c have to be integers, means I cannot have fractions or decimals as a, b, and c, and the greatest common factor of a, b, and c has to be 1. There can't be any common factors in it. A is always positive, so we usually write it ax plus by, not negative ax, and a and b cannot both be 0. So if you look at 3x plus 5y equals 12, to identify, your a is 3, b is 5, and c is 12. So c is all by itself on the other side of the equation. So write each equation in standard form, identify a, b, and c. So I'm going, however you want to say this, okay? The x needs to be positive. So if I take let me get this. Well, let's go here. If I take the 2y onto this side, I would subtract. And if I take the 5 over there, I'm going to subtract. Now, it's an equation, so I can flip it. So when I write it, I got 4x minus 2y equals negative 5. My a, of course, is 4. My b is negative 2. And my c is negative 5. Okay? It is not in standard form if you write negative 5 equals 4x minus 2y. Okay? It's ax plus by equals c. So you start with a, and a is positive. So if you look at b, okay, not only do you have to move the 9 over, but be careful because 3 goes into every one of those numbers. So that means that when I divide everything by 3, 3 divided by 3 is 1x, 6 divided by 3 is 2, and 9 divided by 3 is 3. So that makes my equation x minus 2y equals 3, which means a is 1, b is negative 2, and c is 3. I know y'all think that's pretty easy. Hopefully. All right, one last example, and then I'm done. Example 4, find the x-intercept and y-intercept of the graph of 2x plus 5y equals minus 10 equals 0. Now, y'all are going to have the tendency, or you have many times the tendency to take this equation and solve it for y. But especially if 2 and 5 go into 10 there, it is much easier to graph it with our intercepts. Now, I'm saying that an x-intercept means I have a number and then the y-coordinate is 0. The y-intercept would be if x is 0 and the y is a number. So if I take this equation of 2x plus 5y minus 10 equals 0 and make it the standard equation, 2x, well, I wrote minus 5, but of course that's supposed to be plus 5. 2x plus 5 equals positive 10. Okay, so to get my intercepts, y'all, if I plug in 0 for x, then that means that this all goes away. If I plug in 0 for x, so 5 times what equals 10? Well, y'all know that that's negative 2, and of course it should be positive 2 because I didn't write that down correctly. Okay, 1 second. Okay, let's finish it up. Sorry. So it is a positive 5. So, of course, that should not be negative 2. It would be positive 2. All right. So the next would be, that would be my y-intercept. To find my x-intercept, well, I just did that too fast. To find my x-intercept, I'm going to go plug in 0 for y. So to plug in 0 for y means I'm going to get rid of all of this. And then when I plug in 0, 2 times what equals 10? And of course that answer is 5 because you already saw that. So to graph it, okay, and this is much better than doing y equals mx plus b, y'all, because people make mistakes with those fractions. But to graph it, I'm going to have 0, 2, and I'm going to have 5, 0. And if you need to fill up your graph, you just go left 5 up 2, left 5 up 2, and then you do your best to draw a line. So it's not good because I can never draw these negative slopes. Very well, but that's all you do, and I hope that you will practice that because it is a much easier way to graph a line when it is in standard form. So that's all we have for linear relations and functions. If you have any questions, please don't hesitate to email me or come see me. Thank you so much for watching, and y'all have a great day.